Our group is made up of programmers, engineers, designers, and innovators. We each have our own specific talents, and together we are able to accomplish our goal in a unique and effective manner. We have a common interest in engineering and generally are on the same page about things. The great thing about this group of people is the diversity of skills and the passion put into the work.
We've all been in the same engineering class since freshman year, and together we've been through countless events and competition concerning the engineering field.
As we all know, children grow, with the high cost of most prosthetics ranging from $2,000 for basic functional prosthetics to $100,000 for the more complex prosthetics, according to the Bioengineering Institute of Neuroprosthetics at Rochester Polytechnic Institution. Added to the cost of biannual therapy sessions, this becomes very costly for a young amputee's parents. Additionally, a child amputee with a residual limb is at a major disadvantage, not only physically, but emotionally. What seems trivial to somebody with all their limbs can be grueling and strenuous to an amputee. Our solution to this problem is a fully 3D printed myoelectric prosthetic arm with electronics that interface with a game for therapeutic use.
Our prosthetic uses myoelectric sensors that detect electricity in the muscles when they contract. The microcontroller then tells the motors to either open or close the hand using strings and a gearbox of worm gears that prevent backdraft. The arm will be 3D printed with a nylon composite that is highly durable and tensile compared to other commonly used thermoplastics such as PLA and ABS. Because it is 3D printed, the designs can be as personal or as complex as the user desires. The parts are interchangeable, so repairs and upgrades are made simple and cost-effective. Our design provides comfort to the user by implementing a soft silicone rubber padding where the residual limb meets the prosthetic to relieve strain for long periods of use. Additionally, the exterior was modeled after a human arm to efficiently bear a load.
In order for the user to get accustomed to their new prosthetic, we have developed the concept of an interactive game therapy simulation. The game receives data from the inertial measurement unit via Bluetooth, communicating the orientation of the arm. The therapeutic game will help the amputee become familiar with their new prosthetic and be able to learn the necessary actions to use their arm in a more engaging fashion. Current therapy is very dull and repetitive, requiring the user to repeatedly lift the same object multiple times and other repetitive movements. Our game will provide many different environments and situations that get the user to practice different skills and allows the users to get accustomed to the specific operation of the prosthetic while also determining the range of the residual muscle strength.
To recap, a few things that make our product unique is that because of 3D printing, the exterior is highly customizable, visually pleasing, and low cost. And of course, the parts can easily be replaced. Also, our product includes an interactive game environment for users to get used to our new prosthetic. The arm uses an IMU and Bluetooth to transmit data about the arm's position in space, along to whether the hand is open or closed.
So our next step to bring it to reality is to develop strong relationships with a user base to get a consistent source of feedback for our designs. Next, we want to develop a prototype and start making PCBs or printed circuit boards that can be integrated with other prosthetics so they can play the game too. And lastly, we want to streamline assembly.